In the last video, we derived the quadratic equation, the quadratic formula, using completing the square. And in this video, I want to go over the first example of us actually using it. So problem number 2, well, first of all, the quadratic equation that we found, just to remind you, for ax squared plus bx plus c equals 0, we found that x was going to be equal to negative b plus or minus the square root of b squared minus 4 times ac all over 2a. So this first problem here says use the quadratic formula to solve for x in x squared minus 1 equals 0. And we also want to verify that we get the same answer without using the quadratic formula. It says also that a graph of x squared minus 1 is shown to the right. Clearly that's false. I don't know where it went. So let's first show how to solve for x without the quadratic formula. So we've got x squared minus 1 equals 0. I know that if I want to solve for x, I need to get x on one side by itself, so I'll add 1 to both sides. And this gives me that x squared is equal to 1. Then I'll take the square root of both sides. To give me that x is equal to plus or minus the square root of 1. The square root of 1 is just 1, so we get 2 solutions. We get x is equal to negative 1, or x is equal to 1. And from this, we can draw a quick picture of it, of what this will look like. Here's my x and y axes. Let's say here's x equals 1, and here's x equals negative 1. And if I draw x squared minus 1, that should look like this. Very exciting. This is sort of nice because we can clearly see where the graph of x squared minus 1 crosses the x-axis, gives us the 2 solutions. Okay, so let's also do this using the quadratic formula. So what I'm going to do is, let's remember that the quadratic formula is used to find solutions of ax squared plus bx plus c is equal to 0. So my process for using the quadratic formula to find the solutions to something is I'm going to go through my equation and try to figure out what a, b, and c are equal to. Then I'm just going to plug these numbers into the quadratic formula. So in this case, our equation looks like x squared minus 1 equals 0. This means that a, which is the coefficient in front of the x squared term, is going to be 1. B is going to be 0 because I don't have an x term. And C is going to be equal to -1. And then we're going to take this information and plug it into x equals -b plus or minus the square root of b squared minus 4ac all over 2a to solve for x. And so this might seem a little bit silly to do because on the left-hand side, where we didn't use the quadratic formula, it wasn't difficult to solve for x. But I'm just doing this to show you that it can be done, and to show you it's not so bad. So let's plug in all of these numbers. We'll have x is equal to -b, which is -0, plus or minus the square root of b squared, so 0 squared, minus 4 times 1 times -1, all over 2 times 1. So just a warning ahead of time, be very careful about what's under the square root here, and in particular, what comes after this minus sign. So 4 times 1 times -1 is 4, but I'm actually subtracting that. So I have 0 plus or minus the square root of 0 squared plus 4 over 2 times 1, which is plus or minus the square root of 4 over 2, which is plus or minus 2 over 2, which is just plus or minus 1. So we have two solutions, just like before. We've got x equals -1. Oh boy. Let's try that again. X equals -1 or x equals 1. So our two ways of doing things here do agree. Unfortunately for us, the easy thing, which was the left-hand side, I would say, isn't always possible to do for a quadratic equation. So these do agree.